So again, I asked you to do as many odds as you could. So let's look at the first one. Can you help me set up that first one? Yeah, Griffin, what are you thinking?
Root 12 squared plus root 5 squared equals, well, actually, it'd be backwards.
Oh, it doesn't matter, but you want to do C squared first?
Yeah.
So 4 squared first?
Yeah.
Okay, so we are doing Pythagorean theorem and figuring out if this triangle forms an acute, obtuse, or a right triangle. Ryan, did you have something first?
Yeah, so when we do like, is a square root automatically smaller than 4 or like,
Not necessarily.
you have to like put on a decimal or something?
What we should do is check to see if this even is a triangle, right? So we should decide what's root 12, what's root 5. And see if it works. So I'm gonna go to my calculator and I'm gonna make sure I get the decimal form. Square root of 12. Good. 3.46. Square root of 5 is 2.24, whatever. Are those two smaller than 4? However, if I added them up, will they be greater than 4?
Yeah.
Yes, good. So I do need to see that step a little bit. And I like that Ryan did that just so we can ensure what's C. So once I do that, now we know exactly what we set up is correct. So 4 squared is going to be 16. What's square root of 12 squared? Square root of 12 squared, just 12. What's the square root of 5 squared? 5. No, 5. So then time for games. 16 is equal to 12 plus 5, which is 17. Is that true? No, what should my inequality be?
16 is less than 17.
Less than, so which triangle is this?
Cute.
Acute. Good, so that's why I like to do C squared, because less than automatically goes to acute in my head. Okay, let's jump to number 3. What's going on number 3?
We got 45,
45, 45, 90. We've got a special right triangle in here, okay? I know one of those letters really easily. Thank you, Libby.
Oh, B5.
B5, why, Cameron?
45, 90.
Good, my two legs are congruent. Now what do I do to go from my leg to my hypotenuse, Griffin?
5 times 2.
Times
Root 2.
root 2, very good. So what should A be? 5 root 2, good. Awesome, you guys are doing so good. All right, let's look at number 5 then. We're gonna keep going down with the odds. 30, 60, 90. Which side did I give you? Short leg, long leg, hypotenuse? Long leg. Which side's my short leg?
B.
B. What do I do to go from long leg to short leg? Root 3. 3 divided by root 3. We gotta rationalize by multiplying root 3 on top and bottom. So I get root 3 over 3. Can I simplify that more? Yeah, it's just gonna be root 3. Am I moving too fast? What do I now do to go from the short leg to the hypotenuse? Times 2. So what's root 3 times 2? 2 root 3.
If you're going from the short leg to long leg, go times square root.
Times square root 3. It's always going to be root 3 between short leg and long leg. It's just are we multiplying, are we dividing? Yeah, Griffin.
What if you're going from long leg to hypotenuse?
I don't want you to do that. Because you're going to have to multiply by 2 over root 3 or divide by root 3. You have to do something funny, and I don't want you to worry about that. So just always go through the short leg. All right, let's look at number 7. What's going on here? 45, 45, 90. Okay. What did I give you? Hypotenuse. Good. How do you go from hypotenuse to either one of the legs?
Divide by root 2.
Divide by root 2. Is it the same for both legs? Perfect. 8 divided by root 2. Let's rationalize that. Simplify. 4 root 2. Oh, you guys are killing it. You feeling good? Can we keep going? Okay, let's keep moving. Next one says, find the value of each trigonometric ratio to the nearest 10,000. What do I do?
Put it on my calculator.
Put in my calculator. Ryan goes, that's easy. I love that.
0. I don't know how to do this.
You can check your answer with mine on the board. I'm gonna round that last 3 up to a 4 because there's a 7 behind it. When we're doing it in the calculator like this, yes. In a minute, we will not. In a minute, we'll just do like 1 or 2 places. Is that the bottom of this page?
2.
Amazing. Once you have that done, flip your paper over. Let's look at this next part. It says, find the value for each trigonometric ratio. So if I'm doing my trigonometric ratio, what should I maybe write at the top of my page to remind me all of my ratios? So SOH, CAH, TOA. On number 13, which part of that am I going to use? Cuff. So I'm going to do cuff because I'm doing cosine of X. What angle am I focusing on in my picture? X, very good. Can you label opposite, adjacent, hypotenuse if we're looking from X? Cameron, what do you got?
26 is hypotenuse.
Good, what else?
24 is opposite.
Amazing,
It's adjacent.
great job. Now, I'm not gonna use all 3 numbers. Which numbers am I gonna use?
10 and 26.
10 and 26. So I'm gonna write 10 over 26. Can I simplify that? 5 and 13? Did I do that right? Again, am I moving too fast? Is everybody good? You guys all with me? Okay, awesome, let's go down. Okay. This one says 40, I've got X, I've got 15. Is this a Pythagorean theorem? No. Is this a special right triangle? Is it 45, 45, 90, or 30, 60, 90? No. That means that it's gotta be SOHCAHTOA. If you do not have a 45, 45, 90, or a 30, 60, 90, it is SOHCAHTOA. So I'm gonna use SOHCAHTOA. If this is my angle, can you label opposite, adjacent, hypotenuse?
Yeah.
What do you know?
15 top options.
Good, what else do I know?
Adjacent opposites.
Opposite is X.
That's like us.
That's okay. And then adjacent is the blank side. We don't actually care about adjacent. We don't know the adjacent. Okay, I only have pieces for O and for H. So which trig function am I gonna use? So we're gonna do sine. What am I gonna write? Write your trig function. Which trig function do we use? Sine, good. Sine of the angle. What's my angle? Good. Equals X over 15, good. I don't want to move too fast. Anybody questions? Brian, what's going on?
Oh, why is it so?
Very good. We don't have A, so I only have O and H, and so the only one that has O and H is so. Good question. Yes,
Actually, no. What would happen if the 15 was above the X?
hopefully we'll do another one like that. So let's get rid of this. Let's get the X by itself. What do I need to do to get X by itself? Multiply by 15 on both sides. So I've got 15 sine 40 equals X. Then what do I do? Put in the calculator. 15 sine 40, and I get 9.6. These say round to the nearest 10th, which is just 1 place after the decimal. Oh, okay, I actually want to adjust so I can do what Griffin was asking about. Can we actually, instead of doing 17, we're gonna go do 16? Alex, that was a huge sigh. Alex, I go, so we're gonna switch to 16, and Alex goes, I know it wasn't at me, but it was So well timed, I felt.
Yeah.
No, okay, let's set this up so you can tell me why I wanted to do this one instead. Okay, what, is this a special right triangle or is this SOHCAHTOA? SOHCAHTOA. One, because it's in the same section as the other SOHCAHTOA. Also, I don't have a 30, 60, 90 or 45, 45, 90. Can you label opposite adjacent hypotenuse? What are we gonna label 16?
Oh,
Oh, what am I gonna label X?
A.
A. I always label hypotenuse first, so if you are like, I don't know why you got O and A, label hypotenuse, then go across from the angle that you're at and draw a straight line to the opposite. You want me to do it again?
Yeah.
Yeah. I always do hypotenuse first, and I go across from the right angle. That's hypotenuse always.
Yeah, I get that. I'm just confused about the
O is always opposite the angle that you are looking at. So then A is just the last one.
So if it's an X, I can be A, if it's not across the right angle.
If it's not across from the right angle and if it's not across from my angle. So on the last one, X was O because of where it sat on the picture. Which function am I gonna use this time? Yeah, TOA,
Tangent. That was
tangent. So we'll say tangent of
19,
19 equals
16 over.
16 over X. Ooh, do you see why I wanted to do this one? This is like what Griffin asked about a minute ago. Okay, I am still gonna multiply by the denominator. I'm still gonna multiply by X on both sides. I know that's counterintuitive, which is not what you would think it would be, but I have to get rid of that fraction. Now, I can't plug X tan 19 in the calculator. However, this is like X times tangent of 19. How do I move tan 19 to the other side? Where did I lose you, Cameron?
On the calculator, like, divide, where do you look at 15? Oh, wait, that's. Divide.
Okay. We're gonna divide it from both sides. So we're gonna divide tan 19 because it's being multiplied right now. We're gonna do the inverse operation and divide. So you're gonna literally go put in your calculator 16 divided by tan 19. Oh, were you looking at my calculator, Cameron?
Yeah.
Yeah, that 15 was from the last problem. Oh, I just have to go one place after the decimal, so that becomes a 5. You need to do, I would do 19 and then tan. And then I would just remember what that number is and then do 16 divided by that number. Okay. All right, we're gonna go down to the bottom. Would you rather end on 19 or 20? 20, okay, last one.
No.
Everybody with me? Because this is a little bit different than yesterday. Okay, do you notice what's different about this problem than the last two? We're finding the angle. We don't know the angle. Before we didn't know a side and we did know the angle. This time we're looking for our angle. That's all right. Still start there. Can you label opposite adjacent hypotenuse? Take a second, label your opposite adjacent hypotenuse. I'll tell you the answer in a second. We're on number 20, opposite adjacent hypotenuse. For the angle. Good, Cameron asked a good question. So when we write it, are we gonna just put X in for the angle? Absolutely, so let's do it. Which trig function am I gonna use though? Good. Cosine. So we're gonna write cosine. Normally we write the angle, but we don't know it, so we'll write X. And then I'll do my adjacent over my hypotenuse. Okay, when you go to plug this in the calculator, it's gonna be a little weird. You guys ready to see what we do? Do you notice above your sign button, mine is in light blue. I don't know what color yours is. It says sine raised to the -1. That's what we want. In order to get the X by itself, we need to do the inverse of cosine or the inverse of sine or the inverse of tangent on both sides. So we are gonna have cosine to the negative first of 17 divided by 19. in your calculator, you press second and then cosine. So second cosine and then 17 divided by 19. That is your answer, and that is in degrees. 26.5 degrees. Second, Nolan.
Wait, so that,
That's, okay, so this is where we're gonna team time out. You have gotten credit on this worksheet. You don't have to do any more. Now, do I highly suggest you do more of it? Absolutely. What I want you to do is I want you to submit what you did to Schoology. So if you can get your phone or your iPad out and take a picture of both sides and attach it to the assignments called In Class 8-1 through 8-3. You should have all the odds done because that's what we just did. Okay? Oh yeah, but except for the two that we did that were even, but you should have half of this worksheet done. I want you to submit that to Schoology. Okay? I want you to keep this worksheet in case you want a little bit of extra practice. If you come and ask for help from me, I'm going to take us to this worksheet, okay? Anybody questions? Okay, I'm going to pause you on YouTube. If you have questions, I'll hopefully explain it on Schoology or send me an email.